Hello, everyone. Welcome. Thanks for joining us today for this diagnostic training session. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a Q&A button. Click on that, type in your question, hit submit, and I'll get to those at the end of the session. If you're watching on YouTube, just make sure you use the live chat function wherever it happens to be on your screen, and I'll get to those questions and comments later as well. Also want to say a special hello to Ephraim and everyone watching with him in Winchester, Virginia for his seminar today. So appreciate you joining us. And if you have any questions, Ephraim can type them in on Zoom and we can get to those as well. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. Had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So over time in the Subaru dealership, just became the diagnostic guy in the shop. I don't know if it's because nobody else wanted to do it or what, but that I just seemed to take to it, and that's what I started doing. So all the intermittent problems, the drivability problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher problems that would come into my head. And before that, a bunch of other miscellaneous wrenching jobs. Spent a little over 25 years under hood experience for me. So our topic today is automatic transmission controls and testing. So we're not really focusing on gear sets and bands and things of that nature, the actual mechanical functions. We're going to deal more with the electronics. How do we control the transmission going down the road, things like solenoids and temperature sensors and things like that. So with that, let's take a little trip down memory lane through the history books, so to say. So I'm going to use a Chevy Camaro for all these examples I'm going to use. And we'll just see how the transmissions have progressed from, only decided to go back about 31 years. So 1991 had a 4L60 transmission in it, and really is just minimal electronics in there. It was vacuum and mechanical operated back then. Wasn't a whole lot of electrical to even test on the vehicle, and it just kind of operated on its own. But it did have a speed sensor, had a temp sensor, torque converter control solenoid for the clutch, so it would lock and unlock the torque converter clutch, and then it also had a switch internal as well for fourth gear inside the transmission. So other than that, not a lot going on electrically, but a lot going on mechanically, of course, with valve bodies. And they still have valve bodies nowadays too, but it's just the way that they operate and actuate themselves. So not terribly complex when it comes to electrical there. Let's move up 10 years, 2001. That's 20 years ago. Even more electronics on this vehicle. So it had a speed sensor, a temp sensor, torque converter clutch solenoid. It also had shift solenoids in there. So we went from vacuum operated to electronic operated. Also had a pressure control solenoid, and there were now 25 possible DTCs that we could find on this vehicle as well. Because remember, that last one was pre-OBD2. So really they didn't have a ton of diagnostic codes for it because there weren't a lot of things that would fail. 10 more years. So now we're looking at 11 years ago. 6L50. So now we're up to a 6-speed as well. So that's the 6 inside that part number there. So it's a 6-speed transmission. Even more electronics. So we got an input speed sensor. We got an output speed sensor. We have a temp sensor, torque converter clutch solenoid, shift solenoids, 5 pressure control solenoids, 4 transmission fluid pressure switches, an internal mode switch, and 80 possible DTCs. So we went from 35 codes to 80 possible codes, and way more solenoids and switches and sensors. So this is mainly electronically controlled at this point. So it's going to change the pressures going through the valve body, but it's pretty much all electronic at that point. And then we get up to last year's model, 2021, 10-speed automatic transmission. You notice how maybe 10 years ago, manufacturers started putting more than your usual 4 or 5 speeds on, and that's just for fuel economy, right? So they can get up to a much lower RPM on the highway, but you can still have that off the line, get out, get away from a stoplight type of thing, merging on a highway, that sort of thing. So we have 10 speeds now out there. Even more electronics than before. input speed sensor, output speed sensor, intermediate speed sensors as well. There's 2 of those. Temp sensor, transmission range sensor, transmission control solenoid valves, a quantity of 9 in there, and 107 now possible DTCs in there. So a modern transmission, to diagnose it can take a little while, I would imagine. Going through and trying to diagnose that code and finding out which of the solenoids is the problem. So that's what we're going to talk about, kind of how some of these electronic controls work, so you can hopefully better attack some of these diagnostic problems you're going to find. So let's talk first with how are we going to make it know what we want it to do? Gear selection, right? So in this case, we'll start with a cable gear shift, and this one's off a Subaru, but there's many manufacturers use a very similar system. So in this case, we have this inhibitor switch right here. And this is the manual valve inside the transmission. So this is actually on 4-speed. Not too much electronic control on this vehicle, but it's got a valve that's attached to this. The cable attaches to here, this little post. So when I shift in drive, it pushes this forward. And then this switch here rotates around this center point right here. So this is the switch arm, and it's attached to a pin on the back here. And as it moves, it slides around kind of in a radius there. So it is a simple rotary type switch, just like kind of a knob. Maybe it's got a bunch of detent points in there. You want to test for continuity between pins at each shift point. So there's one for park, there's one for reverse, there's one for neutral, there's one for drive. And then it's also had like a 2 and a 1 down there as well. Proper alignment is key though, because this could cause a no start condition if it gets out of alignment. So there's 3 screws, 1, 2, 3 go in there, and you see how they're kind of oval, elongated. So if for some reason they loosened up or there was damage or something, it could rotate. And if it rotates the wrong way too far, when you're in park, it doesn't sense that it's in park. It thinks it's in reverse, or maybe it thinks it's in drive instead of neutral. It just kind of depends on where it stops. And then it won't send the signal back to the computer. It'd say, okay, I'm in park or neutral. And the computer will say, well, if you're not in park or neutral, I'm not letting you start this. You're not going to start this in reverse, right? So could cause a no start condition in that way. So proper alignment is key. And also they still use switches nowadays as well. Some of the modern switches are internal. If we look back, I think it was on that 6-speed Chevy was the first time we saw an internal gear shift switch. So it's physically internal, kind of part of the valve body. Lets the TCM know what gear it's supposed to be in that case. Then with that, so here is our wiring diagram referring to this gear selector switch, and you'll see it's just a manual switch in here. So these 3 kind of match each other. So park will send a signal down here. If it's in reverse, it sends a signal down here. If it's in neutral, it sends a signal down there, and drive, it sends it down there. A lot of wires involved, because we have 4 wires just to tell it what gear is which, plus a ground, and then plus lighting as well, so we can light it up. Actually goes in reverse in that case. Also in this case, so if we go into reverse, we have to go to exterior lights there. So that is just for the reverse switch, and that's built in to the shifter. And then also we have, or in the inhibitor switch as it were. And then we also have, as I said before, 2 lines that go to the starting and charging system. So if I'm in park, it makes contact, and then it says, okay, it's good to start. If I'm in neutral, it makes contact and says, okay, we're good to start. So only in those 2 cases, if it's off a little bit and that arrow lands in the middle, it's not going to make contact, it's not going to work properly. That's where that alignment thing comes in, like I said. Then we have a lot of vehicles out there as well with sport gear shift. Either they have just a separate gate off to the left there or to the right, and you just shift up and down with the shifter itself. Or oftentimes nowadays we have paddle shift, or actually just a button on the back as well on the steering wheel. So it could be used with or without a cable shift. And it's simple switches for the plus and minus. So in this case, this is on a slightly newer Subaru, I think it's 2011. And that's still at a 4-speed, and it still has that range selector, but it also has sport shift over here. So when that gate moves, or when the shifter moves over into that gate, it's going to flip over the switch and say it's in sport mode. So that does 2 things for us. First thing it does is it changes the shift points and makes it more aggressive, holds on to the gear longer so I can accelerate faster at higher RPM. And the other thing it does is it allows me to now go up or down. So if I flip it up, it'll just hit this little switch, and then it tells the computer shift the gear up. If I go down, it tells it to drop a gear. So it's just simple switches on the side, positive continuity, even not even really positive, negative, just continuity on the switch there. So you just test for continuity between that. And as I said, it could be steering wheel paddles or switches, which could be hardwired on-off switches, or on newer cars in the last maybe 5, 6, 7 years, you might even see a LIN bus on those switches as well. So it just run over a bus line down into the transmission control module as well, and just send data PIDs down that way. So that's basically how most of them do it out there that you'll see. And then of course we have this knob shifter. Now, just taking a look at this, a cursory glance at this. Now, if I'm an automotive designer, automotive engineer, is it a good idea to have the thing that shifts the car, that's a big round knob, right next to another big round knob for the stereo and another big round knob for the HVAC system? And I'm kind of feeling over there. I've got to keep my eyes on them, right? Not sure if that was the best idea. There's other ones that were in the console. That's a little bit better. But in this case, this is not really like a hardwired switch. It is more of a digital rotary encoder. So it can spin it around. It has detents in it. Well, really what it's going to do is it's going to send communication network signals over the network to the TCM to tell it what gear it's commanding. So in this case, we'd use a scan tool to diag it. We can use a scope to a point. All we're really going to be able to see, though, if we use a scope on this situation, is going to be we can see if we got power, we can check the ground, and we can check the CAN bus. So both of these are buses. So CAN bus, CAN bus. So I will test it as a 2-wire CAN bus, and I will see if I have a signal, and if the signal looks good, and if my voltages are okay. If you want more information on that, we have a network diagnostics class video that you can watch as well. But that's really all I could see, because once again, it is PID data. So I can look at it with a scan tool. I can look at the PID data and see, okay, well, the switch is commanding park, and am I in park? Or it's commanding reverse. Is it shifting in reverse? And then you just check and make sure the signals are getting where they need to go. Not a lot of wiring involved. So you could use a scope for part of it. Mainly, you're going to initiate it with a scan tool and just see, okay, what do I see from my PID data here? And you can probably even command it park, reverse, neutral as well. I haven't looked too hard at it, but I'd imagine you probably can. So that's control, our main telling the computer, hey, here's where I want to be. Now we're going to talk about the internal to the transmission, what we're going to talk about with the sensor. So first off, we'll talk about the temp sensor. So just like many other temp sensors on a vehicle, ambient air temperature sensor, coolant temperature sensor, it is a thermistor. So in this case, a negative coefficient thermistor. As temp increases, voltage decreases. Some other manufacturers will have it go the other way. If the temp increases, the voltage increases with it. So it just depends on the manufacturer and what way they decided to set that up. You're going to test for, you can test for voltage, you can test for resistance. So I can test the voltage going through, because the resistance changes, and that's what changes the voltage. And then we check the resistance as well. Most manufacturers will publish a table as to what the resistance should be based upon what the temperature is. Sometimes it's external, sometimes it's internal, part of a valve body. And sometimes it can be difficult to access as well. So if it is part of the valve body, that would be one of the ones where it's probably difficult to access, because internal to the valve body, you have to disassemble a lot of things. Other times it could just be sitting inside the pan or sitting really close to the pan underneath and just kind of clipped underneath. So accessing the sensor itself to test it usually isn't what's going to happen. Usually it's going to be with the harness. You can test it on the harness either right at the breakout where it comes out of the transmission, or back of the transmission control module, or if it's internal, you might have to take things apart. So here's an example on that 01 Camaro. The TFT, or transmission fluid temperature sensor, is a 2-wire thermistor. As the transmission temp increases, thermistor resistance and signal voltage decrease. So that's one of the ones where it goes up, voltage goes down. Cold transmission, voltage is sent through high resistance circuit in the PCM. Warm trans, voltage is sent through a low resistance circuit. Now, this is important to note. Because if I didn't know that, I might get some weird readings and think I had a problem here. So I'll show you what I mean in a second. This dual circuit improves the transmission fluid temperature accuracy over all temp ranges. PCM uses transmission fluid temperature signal to determine shift patterns, engage or disengage torque converter clutch, and determine hot mode operation. Right? So knowing all that. Now, this is information right out of the guided component test right inside the tool. If you have a snap-on tool that has a scope in it, it's going to have all this information in there. And then it gives me a pinout over here. So I have my shift solenoids, high and low control, TFT signals, et cetera, et cetera. And then we can pull up this table from GM. So as we can see, my signal voltage, the resistance changes. So I have a minimum resistance of what it should be. I have a maximum resistance of what it should be. And I have a nominal resistance, which is kind of like your middle of the road. And you'll see the resistance does go down. I start at 100,000 nominal all the way down to 47 ohms nominal. So that's a pretty good swing. If you're testing resistance, it's not really going to trip you up. What's going to trip you up is the voltage. If I'm testing voltage on that, and we'll see if it gets to 104 degrees Fahrenheit, I'm at 1.10 volts. If I go to 122 degrees Fahrenheit, 18 degrees more, I'm back to 3.25 volts. So that would mean, in this case, maybe it's reading down in this range. So if I'm only reading voltage and not reading temperature, I could be testing this and think it's reading incorrectly if I didn't know that it switches voltage from a high resistance to a low resistance circuit somewhere around that 104 degree range. So if I didn't know that, that's why you always need to check your information and read your information to see, do I have a difference in resistance? Because this was a little bit unusual in my mind. I haven't really seen this too often before. So that was just that's why I wanted to put this in here to make you aware. I'm sure there's other manufacturers that do this, but this is just a really good example on a pretty popular transmission with how it works like that. So just be aware. Some transmission temperature sensors work that way. If I'm not testing resistance and I'm testing voltage, I could get thrown off. So just be aware. Now we'll talk speed sensors. So speed sensors, most of the time, it's going to be what we call a Hall effect sensor. So it's going to generate a magnetic field. It's going to be reading something of maybe a tone wheel, something inside, maybe it's a gear actually on some of the vehicles, reads the shaft speed. So it generates a signal. So usually it's a 5-volt signal, could be an analog AC signal as well. Oftentimes it's going to be a digital signal, just a square wave. It's going to read the input and or output shaft speed. And then I think it was that 10-speed GM had 2 intermediate shaft speed sensors as well to read the intermediate shafts. In this case, we'll test for voltage or resistance. Sometimes it's part of the valve body, and in that case, if it is part of the valve body, it can be difficult to access. Other times, if it's external to the transmission, a lot of times that can happen. It can be external to the transmission, can be nice and easy. It's going to be right on the side. Being external, though, I'm going to give you an example on this 09 Subaru Legacy. Being external on some of them are external, some of them are not. So in this case, let me just read through the information and I'll explain in a minute. So turbine speed sensor 1 measures trans input shaft speed and torque converter speed. Turbine speed sensor 2 measures transmission speed. So that's really the output shaft. So input shaft and output shaft. There's my pin assignment there for sensor 1 that is mounted above the bell housing. So in this case, this transmission, this is a 5-speed automatic that Subaru introduced in 05-ish. And they used them up until about 2010 when they came out with the CVTs. There were some weird idiosyncrasies with these transmissions. So first off, the connector is above the bell housing and it's pretty exposed and it's really close to the transmission tunnel. So if I'm wrenching around in there trying to get this in or out of the vehicle and I move too far in one direction or the other, I could break it. And then you would need a new speed sensor. Near middle of driver's side of transmission, near middle of transmission is where it's located. That's where you're tested at the bell housing. But on turbine speed sensor 1, driver's side of the transmission, near the middle of the transmission. So it is in a bad spot, really close to the tunnel, could break it. Turbine speed sensor 2 is inside the valve body, so you would need to test it at the transmission connector. The other point of that, another idiosyncrasy that these particular transmissions have, and I know every other manufacturer has their other weird stuff too, but in this case, this was kind of interesting. So from the factory, some of these, when they were built, when they were installed in the car, some of the transmission harnesses, internal harnesses, were pinched when they put the pan on. So it would pinch the harness and then it would short out, and you would have all sorts of drivability problems. You would have maybe bad readings on speed sensors, temp sensors, things like that. So in order to figure it out, because if you're testing outside the transmission, you might not see it. So in order to figure it out, you got to drain the pan, drop the pan, and then examine the harness. And it usually would kind of loop around the front, and it'd be pinched on a piece of metal in there. And if that's the case and it's worn out, you got to replace the harness. They actually had a bulletin on that where we had to replace a bunch. But that's just one of many. So if it's internal, sometimes you got to test it internally. Sometimes you got to drop the pan or drop the valve body. Kind of depends, I guess, on the manufacturer and the manufacturer's attitude towards transmission repair. Some of them, especially on the newer ones, a lot of CVTs, they don't want you taking them apart, and they just say you're just going to put a whole new transmission in there. Other times, you'll take it apart, you'll do clutch packs, you'll do, depending on how far you want to get into transmission repair and diagnosis too. I know at the dealer, we did everything. We didn't just replace them, we did, tear them all down. So just kind of depends on your comfort level with working with them, because they can be complex beasts. And just how far do we want to get in the diagnosis before we just say, all right, it was a short transmission. Kind of depends, I guess, on how you go through it. But I'm trying to help you so you can test it, and maybe I can just replace this one solenoid and not have to worry about a whole $3,000 transmission. And then in this case, we will be measuring, it is an AC generator on this one. So in this case, we're just looking at AC RMS, and it should say, let's see, vehicle speed at least 12 miles an hour should be more than 1 volt AC. In this case, we see 1.2 volts AC on the meter, and that is indicating we're okay. So it's turbine speed sensor positive and no ground. Turbine speed sensor positive is right there, pin 2. So pin 2 and ground, what we're going to see, and we'll plug in and we'll check it out. All right. Other times, like I have said before, they could be internal of the transmission as well. So this is on one of those GM transmissions we looked at earlier. They are on top of the valve body. So you'd have to drop the valve body in order to test this, because it also has a TCM built into it. And you can see there's the plug there. I'm not really getting to that other than dropping the panel. So sometimes it can be difficult. And I also believe some of them, I don't know if it was this one. I don't quite remember if it was this one or not, but some of them you can't buy it separate anyways. You have to buy it with the valve body. Other things that you have to buy with the valve body sometimes could be the solenoids as well. So just kind of depends on the manufacturer. Some of them have, you can just swap them right out, no problem. Other manufacturers is like, nope, you're just going to replace the whole valve body, and that's what we're going to do. So when it comes to solenoids, there's two different main types of solenoids we're going to deal with on a transmission. We're going to have our on-off solenoid. It's either on or it's off, open or closed. The computer controls the ground side, or it could be the power side, depending on the vehicle and the manufacturer. It's an open and closed function. As I said, it's either open or it's closed. There's no in between. Sometimes it's part of the valve body as well. And when it is part of the valve body, once again, could be difficult to access and difficult to get a new part separate for that as well. Sometimes it's just a full valve body replacement with that. So here's an example of on-off solenoids on an 06 Subaru as a 4-speed. So shift solenoids 1 and 2 are on-off type solenoids. They're power side switched. As I said, it could be either or by the TCM and grounded through the trans housing. So in this case, it's a 4-speed. So if both solenoids are on, I'm in first. If solenoid 1 is off and solenoid 2 is on, I'm in second. If both are off, I'm in third. And then if only solenoid 1 is on and 2 is off, I'm in fourth. So that's just how it's going to switch the fluid between the passages inside the valve body. So in this case, top of bell housing under the air cleaner, there's a big harness up there, and that's the transmission main harness. That's where you want to test it. You can also test timing solenoids, ATF temperature sensors, lots of things right there. Remove the air cleaner to access the connector in this case. Solenoids and ATF temperature sensor inside the transmission, vehicle speed sensor 1 and 2, and turbine speed on the left side of the trans case. Those can also get whacked too. We don't want to hurt those as well. So that's just one way to just see, is it on or is it off? And then if we come down here, road test the vehicle. When solenoid is turned on, meter reading should be battery positive. When the solenoid is off, the meter reading should be less than 1 volt. For to shift solenoid, apply trial for proper solenoid switching in each gear. So depending on how we see, do I see on, do I see off? I could actually use 2 channels on my scope. channel 1 on solenoid 1, channel 2 on solenoid 2, and see how they switch throughout the gears. I could see whether or not they're being turned on or off for diagnosing a transmission problem. The other kind of solenoid we're going to see is pulse width modulated solenoid. So there's a modulated on-off operation. It's open and closed, but there's kind of a variable in between. So computer controls either the power or the ground side, and it is an open or closed percentage, what we call a duty cycle. All right, so duty cycle is, if it's on a 60% duty cycle, that means it's open 60% of the time and closed 40% of the time. Over a short period of time, it's just turning it on and off very rapidly. So if I can hold that pintle open at a certain spot by turning it on or off a certain percentage of the time. So we would look at pulse width modulated. In that case, some manufacturers use just these. Some manufacturers use a mixture of on-off and pulse width modulated. And if it is part of the valve body, once again, can be difficult to access. Here's just another example on a 14 Ford Explorer. And in this case, the torque converter clutch lockup solenoid is a pulse width modulated solenoid. So it's an integral part of the solenoid body, and being so, it is not available as a separate unit. So in this case, that's one of the ones I'm talking about. It's not available. Torque converter clutch solenoid is both power and ground side controlled by the PCM or the TCM on some vehicles. PCM, TCM controls common solenoid power used by all solenoids in order to cut power in case of a circuit fault. Solenoid duty cycle is controlled on the ground side to allow for smooth torque converter clutch application. So we're not just jamming it on and off. We can have a nice smooth transition. We can kind of ramp up that duty cycle in order to open it slowly instead of just full on or full off, and maybe having a jarring type effect with that. TCM controls the torque converter lockup by varying the amount of current applied to the TCC solenoid. When no current is applied, the solenoid is fully released. When maximum current is applied, it is fully applied. Best place to test it is on the opposite end of the transmission pigtail from the case connector, and it is located inside the transmission pan in the solenoid body. Once again, can't get to it very easily, so I'm going to test it externally. And then in this example, we would see a pulse width or a duty cycle test. So it sets it at 5 seconds, and then this scale is a percentage. So I see 70% duty cycle right here. So it ramps up from a 40, about a 60, and about a 70 or so, 75% or so duty cycle going through there. Converter is locked when it's at least 65% duty. So it's going to increase as the converter clutch applies on there. You're going to road test the vehicle and observe the duty cycle percent while driving. So you'll hook up and drive it down. Let's see, on a Camaro, it's a little bit different. That 2011 Camaro we were talking about has a mixture. So it has 2 on-off type shift solenoids and 6 pulse width modulated type solenoids for pressure control. Working in combination, these solenoids control pressure to apply the transmission clutches, as well as control torque converter clutch operation and basic transmission line pressure. These solenoids are not serviceable separately from the TCM. The entire assembly is called the Transmission Electronic Hydraulic Control Unit. Scanners used to view their state. The scanner data displays the hydraulic state of the solenoids, not the electrical state. So it tells you whether or not it's actually working. The 2 on-off shift solenoids allow oil to flow through to move to appropriate clutch select valve when on hydraulically. Clutch pressure control solenoids control pressure at each clutch. Chart that follows shows the solenoid state as normally high or normally low. Normally high solenoid allows pressure to travel to a clutch when the solenoid is turned off, whereas normally low solenoid allows pressure from getting to the clutch when the solenoid is turned on. And then we can see where it's normally closed or normally open. So you can see the on-off apply chart. Go down a little bit further, we can see the mixture there. So first through 6th gear, park, reverse, neutral, we can see the different states of the valve, depending on that. You can also do pressure testing as well with line pressure using a scanner and a pressure gauge. You want a 500 PSI pressure gauge, or you could use a pressure transducer. And you can match the commanded value of the pressure value shown. So there's my flow chart right there. So if I command 200, I should see 100 to 130 on my gauge or my pressure transducer. Right. So all the pressure control solenoids are programmed by the manufacturer to operate correctly together with the vehicle that the transmission is installed into. After being programmed to operate within a general set of parameters closely matching the assigned vehicle application transmission was designed to operate with, the transmission needs to be operated through a number of shift cycles in order for the TCM to make the necessary pressure adjustments required for smooth and efficient shifting. So that brings us to the subjects of adaptives. So many manufacturers nowadays use what we call adaptive shift patterns or adaptive adaptations. So, couple things here. This is on a Dodge Challenger in this case. To equalize tolerances and wear, an automatic adaptation takes place for shift time, clutch filling pressure, and torque converter lockup control. Adaptation may be stored permanently and to some extent can be diagnosed. Otherwise, they also have a driving style adaptation. The shift point is modified in steps based on the information from the inputs. The control module looks at inputs such as vehicle acceleration and decel, calculated by the TCM, the rate of change as well as the position of the throttle pedal, fuel injection information from the PCM, lateral acceleration, which is calculated by the TCM, and gear change frequency. Based on how aggressive the driver is, the TCM moves up the shift so that the present gear is held a little longer before the next upshift. So it allows you to drive more sporty when you're driving more sporty. If the driving style is still aggressive, the shift point is modified up to 10 steps. If the driving returns to normal, then the shift point modification also returns to the base position. So this is an active driving style adaptation and only takes over when you're driving aggressive. This adaptation has no memory. The adaptation to driving style is nothing more than a shift point modification meant to assist an aggressive driver. The shift points are adjusted for the moment and return to base position as soon as the inputs are controlled in a more normal manner. And then here we are on the 2011 Camaro. There's also some service functions that need to be done. So in this case, service fast learn adapts is a procedure for 6-speed automatic transmissions in which a series of tests are run to allow the transmission control module to learn individual clutch characteristics. Once the clutch data is learned, service fast learn adapts translates it into the adaptive data cells which the transmission uses for clutch control during shifts. Scan 2 provides initiation of the service fast learn adapts procedure. This procedure is to be used following transmission repair. So anytime I do a transmission internal service or overhaul, valve body repair or replacement, control solenoid valve assembly replacement, TCM software calibration update, or any service in response to a shift quality concern, we want to perform the adaptation after the repair is done. All right. So let's talk about a little bit more live on the tool. All right. So let me have a little drink here. All right. So I have a 2014 Ford F-250 Super Duty loaded into the tool. There's a couple different things we can do, and I picked this one on purpose because there's a couple cool little functions that we have in here that not every vehicle has. First off, though, we do have the guided component tests on this, so a lot of vehicles have this. But if you have a snap-on tool with the scope, so any of the tools have scope multimeter function, also have guided components. And if you don't know what guided component tests are, they are a database of over 5 million guided tests on different components. Goes back all the way to 1981 vehicles. Covers most of the vehicles we also cover in the scanner, and it is real world hookup information. We saw a lot of those screens throughout the presentation already with the pinouts and such. So you'll notice once I load into the vehicle, I have system, and we also have a transmission system. So it's more than just engine and stuff. We can go into transmission as well. So this is a Torque Shift 6, and you can see all the different things that we can test on this transmission in here. So let's say that we suspected we had a problem with the shift solenoid. So we can go into shift solenoids here, and we have component information. So the Torque Shift 6 transmission may also be referred to as a 6R140. This is a 6-speed electronically controlled transmission which uses planetary gears. Gear selection is achieved by the electronic control of transmission fluid flow to operate various internal clutches. It's going to tell us all about the internal stuff. There is a lot of information in here, and I'm not going to read through this whole thing because we only have a little bit of time anyway. All the solenoids except may be serviced without removing the solenoid body. So there's one solenoid you can't, but everything else can be serviced. They're all on the back of the transmission, actually. Solenoids are calibrated from the factory and are not all the same. To replace a solenoid, match the replacement solenoid type, either normally high or normally low, and the band number, we'll talk more about that in a second, with the original solenoid, or harsh erratic shifts, harsher shaft engagement, or damage to the transmission can occur. So I want to put them in the right place. And we can see the different shift solenoids. We have A through E, and then torque converter clutch and line pressure control solenoids in there as well. So we have all of those different solenoids. So once we have all this information, We can also do diagnosis with a scan tool as well, but if you want to test the solenoid for actual functions, you can go in there. Let's see, if TCM or transmission case connectors are disconnected and the ignition key is turned on, transmission and engine trouble codes will be set. If code set, use the scanner to clear once they're reconnected. So we don't want to disconnect it. We always want to have it connected in this case. And it always tells us how we're looking at the harness too. So harness side, back probing the transmission connector. So in this case, plugged in, back probing. And then the test we can do on this is a resistance test. So going to go to solenoid power, and then for the red channel, and then the blue one goes to, depending on whichever solenoid we're we're checking. Key off, each solenoid resistance should be about 4.8 to 5.4 ohms. Outside of that, got a bad solenoid. So let's say we test the solenoids and one of them is bad. Maybe two of them are bad. Doesn't really matter, but a couple, at least one of them is bad. And I need to order that solenoid. And maybe I find out before I want to order it before I tear apart the transmission, because I don't want to leave this vehicle unmovable in my bay. I don't feel like pushing it in or out either, right? So instead of draining it, dropping the pan and all that, there is a scan tool function on some Fords that we can do to actually tell us what solenoid is in there at the time. So I'll switch back over to my scanner here. And then it's going to be, I could go inside the transmission itself, or if I have a tool that has the service resets and relearns, I can go in there as well. It's going to help us kind of collect a lot of the information we need all in one place. So we go down here a little bit. I'm going to go into the transmission, and then let's say reset or relearn the transmission valve. So that is part of the valve body. So we actually have a job related to that. Any related TSBs show up, any functional resets and calibrations that are required for it as well. So we can see on-off shift solenoids, harsh shift, firm shift, gear commands, and then we also have this transmission characterization and solenoid identification. So we'll get in there in a second. That's the test we're going to use. But first, I want to learn a little bit more about this. So if I have Shopkey or Mitchell on this tool, which is a Zeus, I can go into repair information, and it'll link me right to it. So in this case, 2014 Super Duty, King Ranch, because that's the cool one, right? It's going to pass my login through. It's going to pass the vehicle through, and it's going to do a search for my search term. So let's say overhaul or replace the valve body, either or should work. Just for the solenoid, really. Call it four-wheel drive. And then, so we have TSBs, top repairs, testing, OEM testing, guided component testing. Let's go to remove and replace. This is going to tell us some things. So let's say we want to overhaul the main control, and we'll look at the solenoids. So as you can see in this chart here, my solenoids plug in, 7 of the solenoids plug into the back of that valve body. So you can actually get to them fairly easy. Once you drop the pan, you can get there, but you don't want to have to drop the pan to figure it out what they are. It tells you how they work. Then we have the upper valve body there. It's going to give us all sorts of diagrams and information. I'm going to go down a little bit further. You can see where those solenoids are right there. Disassembly, we got some bolts. Down a little bit further. There's a lot of information in here talking more about taking the valve body apart. I don't really care about that. I want to get to my picture of the solenoid. It's a little bit further, not too far. There we go. Talking about the bands. So there's my solenoid here. And if we look, we got our O-rings and we got our filter, and then we have this band number right here. So in order to find this, to order the right solenoid, I need to know what this is. And there's only 2 ways to do it. Either look at it, which means dropping the pan, draining the pan, all that good stuff, or I can do the scan tool function. So I need to know whether it's normally high or normally low, and then I need to know what band number's on it. Otherwise, it will not shift properly when I replace it with the wrong one. So I'll flip back to my scanner. I'm going to go into that transmission characterization and solenoid identity. Key on. And then we see the characterization. It's going to tell me what kind of transmission's in there. I need to make sure it's the right one. It also does it through the bands as well. So we're going to kill two birds with one stone, and we're going to go in. This function is used to obtain the transmission solenoid band information for ordering individual replacement solenoids. Refer to the vehicle workshop manual for further system details. Continue. Not supported on all transmissions, but it'll tell me this is my transmission characterization we were talking about. So it's a 6R140, 13-digit solenoid body, 8-digit solenoid identification. Yes, and there's also a tag on the transmission that will tell you that. This function will provide transmission solenoid band information for individual solenoid replacement. Solenoid body strategy or identification will be required to obtain the solenoid band. This function can be obtained from the module or the transmission service tab. Current transmission strategy, there it is again. And then it's going to tell us what solenoids are what. So if I needed to do transmission solenoid D, I know when I call the dealer, I need to order a normally low. If they want the base number, it's there. The element number is there. And then the band number is there too. So that will just give us all that information. I could, of course, screenshot that, print it out if I wanted to do it that way as well. Hit continue, and we're done. So all it's doing is reading the data out of the transmission, showing it on the screen. Makes it easy enough to do. That way I can order the right solenoid. Like I said, you might have to wait 2-3 days or more, depending on the vehicle. And I don't really need that vehicle, drain the fluid and all that just to check the solenoid. So that's a pretty handy dandy little test. And that's been in the software for quite some time now too. So I thought that was kind of interesting. Bring that to your attention if you do any work on Ford trucks. So there may be a few out there that do that. Hopefully that'll be helpful. And hopefully you gained a few other little tips and tricks and tidbits throughout the evening. I tried to cover a decent variety of transmission types and styles to hopefully get you a little bit more spooled up on what some of the manufacturers are doing out there. I know some of you are going to shy away from diagnosing transmissions, and I don't blame you because it can get a little complicated. But if you want to dive in or if you want to start learning a little bit more, it's definitely worth the time. Just to go through and be able to diagnose a little better, because sometimes a drivability problem is not the engine's fault, it's the transmission's fault. A lot of times those torque converter control clutch solenoids can cause that problem too. So hopefully we got a little bit more out of that, and hopefully you can join me next week as well. So next week we are talking about variable valve timing and also variable valve lift, because some manufacturers use one, some manufacturers use the other, some manufacturers use both. And then some manufacturers use this totally wild, whacked out thing that we'll talk about as well. So that's our training topic for next week. Same time, same place, 6 and 9 Eastern. If you want to join on Zoom, go to snapon.com/OT to save your seat. The early class at 6 o'clock goes to YouTube at youtube.com/Snap-on Diagnostics. If you're watching on YouTube right now and you're not subscribed, please hit that subscribe button and the little bell notification. That way you'll know anytime we go live or post other material, because I'm not the only one who puts content on this page. And, we try to keep it free. 9 p.m. goes to Facebook Live. So if you want to follow me on Facebook Live or follow my Facebook page, it is snapon.com/SnapOnJason, all one word, no dash in the Snap-on. And you can follow me there for 9 o'clock. Try to give you as many opportunities as possible for going through and learning a little bit more about diagnosing vehicles. Try to give you as much free training as we can. If you want to check out any of our other previous topics, we have them all recorded to our YouTube channel. Again, youtube.com/Snap-on Diagnostics. 37 different episodes going everywhere from ADAS, data bus testing, all the way through component testing. We did those over the summer, chassis electronics, etc. So 37 different topics, all about half hour, 40 minutes long. So if you want to check those out, you're more than welcome to. They are 100% free. They're all on a playlist too. So that makes life a little bit easier. All right, let's get to questions. But before I do, I want to make sure I talk about my buddy Al as well. So Al also does diagnostic training for us, and he does it 3 nights a week. So it is tool-specific training, or we call it platform-specific training. So Monday it's on Apollo, Wednesday it's on Zeus, and Thursday it's on Triton. So first hour for any of the classes, pretty much the same stuff. It's going to be, let's get your Wi-Fi set up. And then let's get you hooked up with the free Snap-on Cloud service. So you can upload your pre and post scans, upload your screenshots, etc. Share them with your customers. Hopefully get paid for some diagnostic time. Like I said, that's all free. And then he goes through code to completion. Let's walk through all the functions of Fast Track Intelligent Diagnostics and how does it help me as a technician work faster, smarter, easier, diagnosing a vehicle. It doesn't matter what level technician you are, it's going to save you time because it automates a lot of the process you may already be doing, and it's just going to save you a little bit of time there. So that's the first hour. On Wednesday and Thursday on Zeus and Triton, since they have scope and meter functions, he has another hour after about a 5-minute break in the middle. Goes through all the scope, the meter, the guided component test, all the different functions and buttons, and here's how to set it up. Couple real world examples in there. So definitely feel free to check that out as well. Go to snapon.com/OT to sign up. These are designed to be more of a, I'm going to have my tool in front of me and follow along as Al does on the screen as well. So he really kind of takes his time, go through it. If you get stuck, you can always put a question in the Q&A or the chat and just say, hey, can I see that again? That sort of thing. So trying to help you out with that. Make sure you get all set up and have a good first experience or continuing experience with your tools. So, all right, with that, let's get to Q&A. Okay, so Andrew has a question. It's probably back from some of my material a little bit earlier, talking about fast track intelligent diagnostic. So Andrew on Zoom says, how to understand in the TSP top repairs for PO300, some parts like spark plugs replaced 1,053 times. So that graph that you're talking about is going to have the most common fixes for that particular code on that particular vehicle. And it is based on billions, over 2 billion real world repair orders. So based on a PO300 on a 2016 Tahoe, what showed up on that repair order that fixed that P0300? So if I saw a spark plug replaced 1,053 times, that's over the course of that 200,000 mile graph. We found spark plugs are replaced 1,053 times. And then spark plug wires would be this many times, and so on and so forth. So it's overall over that life of that graph. It's not just, each time on each vehicle. It's based on those, say, 200,000 repairs that we have on a 2016 Tahoe with a 5.3 with a PO300. It's drilled down to that level where we can see, okay, what has happened out there in the real world, in the real shop. So that's how you'd interpret that. Good question. And Ephraim says, no questions in Winchester. So very good. Thanks for dialing in tonight. Thank you for that. I also see somebody else, Carlos, is dialing in from Winchester on YouTube as well. I don't know if he's sitting in the same room as you or not. And he's just sitting on YouTube on his phone. Maybe, maybe not. But definitely welcome there as well. So let's check out YouTube. We got a lot going on tonight. Looks like people are checking in from all over the place tonight. We got a good little trend going. So let's see. GIE Auto, good afternoon. Thanks for checking in. Mike's Automotive Diagnostics, welcome. Thank you. I am No Sleep from Calgary, Canada. Nick is saying hello from everybody around the world. I know he's dialing in from the UK, and it's very, very late at night, but thanks for joining. Con Automotive, Saskatoon, Saskatchewan, right? That's what that is. Abel Gracida from Phoenix. And let's see. Nick enjoys the tutorials, loves his Snap-on Zeus, as always. Ray, you're a little bit late, but that's okay. You can always watch the replay there. Hello, the Winton 29. Thanks for checking in. Always good to see you. Jose Salas, hello. Let's see. Mike's Automotive Diagnostics talking about a torque converter clutch solenoid. So had a torque converter clutch solenoid on a GM that tested good electrically, but no pintle hump on the scope. Checking your amperage. Very good there. That means it's actually not opening. So changed it and it worked great for about 300 miles. Then the entire transmission just went shot. So yeah, I guess that happens too. Found metal in the solenoid. Lesson learned. There you go. Yeah, absolutely. Metal in that solenoid is gonna cease to work at that point. All right. Let's see. I am No Sleep. Thanks for checking in again. Carlos from Winchester, Virginia. Good to see you. And Shifting Gears, Provo, Utah. Welcome. Thanks for checking in there as well. Let's see. Andrew has another question. Testing ignition coil current ramp with low amp probe, 20 amp jaws, clamping to positive wire to ignition. Is it the same to check ignition spark plug wires? So no, you would not necessarily. I wouldn't use a current ramp on the actual spark plug wire itself. So the spark plug wire, the special adapters for that, you would want to use an inductive spark or secondary ignition clamp in order to test secondary ignition like that. So you really don't use an amp clamp for that. You would only really use that on that positive side. Yeah, thanks. Glad I could answer your question there. Appreciate that. All right. And then Fonz is checking in from Ann Arbor Auto Care. Thank you very much for the love. Definitely appreciate you taking time out to check us out. So with that, looks like we cleared the board there. Definitely appreciate everybody checking in from all corners of the globe. Thank you very much. And I'd like to thank you for taking a little bit of time out of your busy day to come spend with us. Hopefully we learned a few more tips and tricks diagnosing transmission, electrical components, and electrical systems there. Hopefully you can join me next week for variable valve timing, variable valve lift, all that other fun stuff. We'll be back live and in person as usual, well, live and virtual anyway. So enjoy the rest of your week. Enjoy your weekend. Hopefully we'll see you next week. Enjoy and take care.